In this video, we'll be talking about student loans and home buying. Our learning objectives are to learn how to compute the interest on a student loan, how to compute payments on a student loan, how to find a monthly mortgage payment, how to find the total interest on a home loan. We will look at how to compare two mortgages with different lengths, and we will wrap up by briefly talking about how to make an amortization schedule for a home loan. Now, there are three basic types of loans that most undergraduates might consider. Federal loans made by the government, federal loans made by banks or other lenders but guaranteed by the government, and private loans. In general, federal loans should be a student's first choice because of the stability. The interest rates are fixed for the life of the loan, and they are regulated by Congress, so you're unlikely to end up with a nasty surprise somewhere down the line. There are, however, limits on the amount that can be borrowed for one student loan, for one student through federal loan programs, and private loans might be the only alternative for an especially expensive education. Other than the length of the loan, the big difference between student loans and other installment loans is that the payments are typically deferred until after graduation. This makes a lot of sense, as in many cases, students aren't working enough to make the money required to keep up with the payments while they're going to school. So that's a good deal. But it does come with a catch. In some cases, interest will accumulate on your loan while you're in school, even though you're not making any payments. This can increase the principal balance considerably. The loan term can vary depending on the amount borrowed, but the standard term is 10 years with payments deferred until 6 months after graduation, to give you some time to find a job after you graduate. Interest on student loans is simple interest. The interest accrues only on the principal balance, not on previously accrued interest. So while the student is still in school, the amount of interest that accrues each month remains constant. The interest is calculated using the simplified daily interest formula. So these are our formulas. Annual interest is principal balance times interest rate. And note that this is just an application of the simple interest formula that we've been using for many of our examples. Simple interest formula is interest equals principal times rate times time. And over here, the annual interest would just be principal times rate times time, but where time is just 1 year, right? So we don't put it in there because it's just times 1, so we don't need to bother writing it. But annual would be interest for 1 year. So it's just the simple interest formula where t equals 1. If I want daily interest, then I would need to take the annual interest and divide it by the number of days. That would be 365.25, because that's exactly the number of days in a year. The monthly interest then would be the daily interest multiplied by the number of days in a month. It's going to be a slightly different if you're talking about a 30-day month versus a 31-day month, or February, a 28-day month, or a leap year if it's a 29-day month. But you would just multiply it by the number of days in the month. Okay, let's walk through some examples. Start with example 1 here, where we look at how to compute interest on a student loan. Let's say that Sonia borrows $6,500 to cover one-time college expenses in a federal student loan program at 6.8% interest. So the first thing we want to do is find the monthly interest for 30 and 31-day months. So let's start with that. So using the formulas on this previous page, we want to take the principal balance and multiply it by the interest rate, and then we'll divide that by 365.25. So we're basically going to use this formula right here to find the daily amount, and then we'll multiply that by 30 to find the monthly amount for a 30-day month, and 31 to find the amount for a 31-day month. So starting with that formula, let's see, principal balance. Okay, so we've got, we're going to do daily interest amount Okay. This equals the principal balance multiplied by the interest rate and that gets divided by 365.25. All right. So the principal is the amount borrowed. That is the $6,500. Okay. So 6,500. The interest rate is 6.8%. As a decimal, that's 0.068. Divide that by 365.25 to get a daily interest amount of $1.21. Okay, so for a 30-day month, let's do those calculations down here. Let's see, 30-day. Sorry, that was a mistake. Day, month. Okay, we would have 30 days times $1.21 each day, and that works out to be $36.30 of interest on a 30-day month. 31-day month. Okay, we would have 31 days times $1.21. So in a 31-day month, the amount of interest accrued would end up being $37.51. Okay, part B. How much interest will accrue while Sonia is still in school? Assume school starts in August, graduation is in May, 3 years and 9 months later, and payments begin 6 months after graduation. Okay, so we've got 3 years and 9 months plus an additional 6 months. In total, that is 4 years and 3 months. 4 years and 3 months, right? That's the amount of time that interest will accrue before she starts making payments. So we've got 4 years and 3 months, and let's see. So graduation is in May, right? And then she's got June, July, August to round out the year. And then the 3 months, we're saying 4 years and 3 months. The 3 months are September, October, and November. Okay, so we're talking about, this is part B. This is part A up here. This is part B down here. Okay, so interest will accrue for 4 years, 3 months. The 3 months are September, October, and November. September, October, November. Okay. So that means we have 2 30-day months and 1 31-day months. So what's the total amount of interest accrues? Well, let's just start with the 4 years. Okay, so the 4 years, total interest. So the 4 years using the simple interest formula would be principal, which is 6,500, times rate, which is 0.068, times time, which is 4 years. So that's the amount of interest for just the first 4 years. If I can just clean this up a little bit. Okay. And then we have to add the interest for the 3 months onto that as well. So that would be the September, the October, and the November. 2 30-day months. So that would be 2 times For a 30-day month, we said it was $36.30. $36.30 plus the interest for one 31-day month, which we said was $37.51. Okay. So you need to pull out a calculator to do that calculation. It's not a hard calculation, but you need a calculator to help you with that. And you should end up with $1,878.11 in interest in total. Okay. So when she starts paying her loan, making her loan payments, this is the amount of interest that will have already accrued at that time. Now, there are some loans where interest is covered by the government while the borrower is still in school. This type of student loan is called a subsidized loan. Okay, so this is subsidized. Okay. If interest is added to the principal while the borrower is in school, the loan is called unsubsidized. Okay. For the loan in example 1, the example we just looked at, the student would have saved $1,878.11 by acquiring a subsidized loan because the government would have covered that amount. Okay. So that makes it pretty obvious that this type of loan is always the best choice if possible. When monthly payments begin on a student loan, they're based on the principal balance at that point in time. These payments can be computed using the following formula. So this is the formula for monthly payments on a student loan. For a 10-year student loan with principal P and interest rate R, written as a decimal, the monthly payment is given by this formula. Okay. So let's look at an example where we use this formula. Finding the monthly payment on a student loan. So we want to now find the monthly payment on the loan in example 1 if the term is 10 years. So what we did in example 1 so far is we found the total amount of interest that accrues by the time the student starts making payments. That's the $1,878.11. So in this example, we found that the interest accrued before payments start, right? So what we need to do is figure out the principal at the time the student starts making payments. So that would be the loan amount, which is $6,500, plus the accrued interest, which was $1,878.11. And this is equal to $8,378.11. And that's my value of P that I'll plug into my monthly payment formula. Because when the student starts making payments, that's the principal, that's the amount of money that will ultimately need to get paid back, right? The borrowed amount plus the already accrued interest. So let's write our formula down here. R equals P times, let's just do it slightly differently here. P times R over 12 over 1 minus 1 plus R over 12 raised to the power of negative 120. Okay. If I plug in the actual numbers, my principal is $8,378.11. My interest rate as a decimal is 0.068 over 12. This whole thing is over 1 minus 1 plus 0.068, my pen is over 12, raised to the power of negative 120. Okay. Again, sorry for the sloppiness. I'm having some trouble with my pen again. And this you'll have to work out carefully using your calculator. If you work out just the numerator, the 8,378.11, if you multiply that by 0.068 and divide by 12, you should get 47.48. If we just work out what's inside of the parentheses right here, we should get about 1.005. About 66667, if you round that down a little bit. And that works out to be about $96.42. Okay. All right, so that would be the monthly payment. Let's talk about some other terminology here. When interest on a student loan is not paid during college, we say that the interest is capitalized. As we've seen, when interest is capitalized, it adds to the principal balance, resulting in larger payments. When interest is not capitalized, payments must be made during college, but only covering the amount of interest, not the principal. Okay? So let's break this down a little bit more here. When interest is capitalized, no interest is paid while the borrower is still in college. The principal balance continues to grow while in college. The resulting payments will be larger. When interest is not capitalized, interest only is paid each month while the borrower is still in college. The principal balance doesn't grow while the borrower is still in college. The resulting payments will be smaller. So note that these apply only to unsubsidized loans. For subsidized loans, there is no interest while the borrower is in college because the government just covers that amount. So there's nothing to capitalize. So these concepts only apply to unsubsidized loans. Okay, the monthly payment calculation we did in example 2 included the accrued interest, which means interest was capitalized on that loan. That was an example of a capitalized loan. Let's see how not capitalizing interest would affect the monthly payment. Okay, so if interest on the loan in examples 1 and 2 is not capitalized, we want to find the interest payment while Sonia is still in school, find the payment on the loan when the full payments begin, and then we want to figure out how much less would Sonia pay in total if interest was not capitalized. Okay, let's take these one at a time. Part A, we actually already did this in example 1. The interest that is due each month will be the interest that accrues on the loan at the rate of $1.21 per day. Okay, so the student will owe that amount times the number of days in any given month. Okay, so Part A is basically what we did in example 1. Okay. Part B, find the payment on the loan when full payments begin. So this is different from example 2 because in example 2 we were talking about a capitalized loan, right? Where when she started making the payments, we had to factor in the loan amount plus the already accrued interest, right? But with a capitalized loan, she would be making interest payments while she's in school. So she would have already paid the interest, right? So that means when full payments begin, because she's already been paying the interest, then the principal balance at that time would just be the $6,500. Okay, so our monthly payment formula is P times R over 12 over 1 minus 1 plus R over 12 raised to the power of negative 120. Okay. So because she's already been paying the interest, when she starts making full payments, she's only going to have to pay the principal balance, which is the $6,500. Okay. Interest rate is still 0.068, 6.8%. Okay, so nothing else changes here. If you do this calculation, you should get $74.80. All right, how much less would Sonia pay in total if interest was not capitalized? Okay. Well, in the previous example, we found that when all interest is deferred, Sonia would make payments, what we did figure out, of $96.42, right? And she has to make those payments for 10 years. So there are 12 payments a year. For 10 years, that would be 120 payments. Okay. So in that case, we would have 120 payments times $96.42 for each payment. Okay. That works out to be $11,570.40. Okay. Now, if the loan is capitalized, that means that she's already been paying the interest, right? So that means there would be her monthly payments would be this size right here. Okay. So there's still 120 payments, but this time the payments are smaller, $74.80. Okay. That works out to be $8,976. But then we also have to factor in the interest paid up front, because she's been making interest payments while she's in school, right? So we would take the $8,976 and add in the upfront interest, which was $1,878.11, and that works out to be $10,854.11. So the two numbers we want to compare are this number, the $11,570.40, and this number, the $10,854.11. This number right here is the total amount paid if the loan is not capitalized. This is the total amount paid if the loan is capitalized, okay? Is by not capitalizing, okay? So by not capitalizing the interest, how much is saved? Well, we would take the $11,570.40 and we would subtract $10,854.11, and that works out to be $716.29 over the life of the loan. Okay. So if you are thinking about taking out a loan, this is the kind of calculation that you should do so that you can decide if making those payments while still in school is worth the overall savings that will result, right? Just having a sense of, if you choose one option versus another option, the total amount of money spent under each option it's a good idea to figure that out. So you just know kind of what you're getting yourself into either way. Okay, let's turn our attention now to home buying. So home buying, home loans are typically called mortgages, and these are long-term loans that are paid over typically a 30-year span, although they can be for shorter or longer time periods as well. But a 30-year loan is a major commitment and one that nobody should enter into without an understanding of the mathematics that go into the process. So in the remainder of this section, we'll take a look at that math, hopefully helping you to become a more well-informed home buyer. Okay, let's define some terms. A mortgage is a long-term loan where the lender has the right to seize the property purchased if the payments are not made. Homes are the most common items bought using mortgages. The most common mortgage term is 30 years, but they are widely available in terms from 15 to as many as 50 years. There are several types of mortgages. One is a fixed-rate mortgage. This just means that the rate of interest remains the same for the entire term of the loan. The payments which are usually monthly, stay the same. An adjustable rate mortgage means that the rate of interest may fluctuate. So that means it could increase or decrease during the period of the loan. Some lending institutions will allow you to make graduated payments. This means that even though the interest doesn't change for the period of the loan, you can make smaller payments in the first few years and larger payments at the end of the loan period. So, let's take a look at how to find the monthly payments and total interest for a mortgage. The monthly payment formula that we use for student loans is actually a special case of the formula we will use for home loans. The only difference is that we adapted that formula for a 10-year term, which is typical for most student loans. Home loans come in a wide variety of terms, so we will want to be able to adapt to different lengths. This more generalized formula also allows for payments at some regular interval other than monthly. Okay, so here's the formula that we will use for computing monthly payments on a mortgage. R is the regular monthly payment. P is the amount financed or the principal. Lowercase r here, written as a decimal, is the interest rate. N is the number of payments per year. And then T is the number of years. All right, let's go over a few examples of using this formula. First of all, let's try finding a monthly payment. After a one-hit single, a young singer unwisely decides that she needs a $2.2 million mansion. With some of the proceeds from her album, she puts down $500,000, leaving $1,700,000 to finance at 6% for 20 years. So we want to find the monthly payment. All right, so let's write down the formula. R, equals P times R over N over 1 minus 1 plus R over N raised to the power of negative N times T. Okay. So let's, what are the actual numbers we have? Well, the principal is the amount financed. That is the $1,700,000. The interest rate as a decimal is 0.06. N is the number of payments per year. We're going to assume that's 12 because typically it's a monthly payment. Okay. Find the monthly payment. And then T, it says, for 20 years. So T would be 20, it says right there. Okay, so if I plug all these numbers in, I get 1,700,000 times R over N, which is 12, divided by 1 minus 1 plus 0.06 over 12, raised to the power of negative 20 times 12, okay? I'm going to come down here to work out the rest of this. So if I simplify this down, the numerator becomes 8,500, okay? In the denominator, I end up with 1 minus 1.005 raised to the power of negative 240. And that works out to be around, if I round to the nearest cent, $12,179.33 as a monthly payment. That's a lot of money to pay every month. So she better hope that her next album does well too, if she wants to make those sorts of payments. Let's look at another example, and this next one is maybe a slightly more typical case. Let's say that the Petty's family plans to buy a home for $174,900, and they have been offered a 30-year mortgage with a rate of 4.5% if they make a 20% down payment. What will the monthly payment be with this loan? Okay, so again, using the monthly payment formula, P times R over N over 1 minus 1 plus R over N raised to the power of negative N times T. So what's P? Well, P, we might think that P is the 174,900, but it's not that because they make a 20% down payment, right? So they take 20% of this and they pay that up front, and then they borrow money to pay the rest. So the principal is actually going to be the remaining 80%. So it would be 80% of this number. So we would say 0.80 times 174,900. That works out to be 139,920. That is what is borrowed. The interest rate as a decimal is 0.045. N, it's a monthly payment, so N would be 12. And this is a 30-year loan, so T is 30. I plug all those numbers into my formula. I get 139,920 times 0.045 over 12 over 1 minus 1 plus 0.045 over 12 raised to the power of negative 12 times 30. Okay. And again, if I kind of break this down in a step-by-step fashion, the numerator ends up being 524.7. In the denominator, I get 1 minus 1.00375 raised to the power of negative 360. And plug that into your calculator, you get approximately $708.95. That's a much more reasonable monthly payment than the $12,000 in the previous example. It's actually a pretty eye-opening experience to calculate the total interest on a mortgage. To do this, we multiply the monthly payments by the total number of payments and then subtract the principal. Let's do that here in example 6. Find the total amount of interest on the Petty's family would pay if they take the loan in example 5. So we said it was a 30-year mortgage, right? So the number of payments Okay, we would have 30 years and 12 payments a year, so that's a total of 360 payments. And in the previous example, we calculated that each payment was $708.95. So the sum of all payments that would be the monthly payment size, $708.95, times the 360 payments, and that works out to be $255 and 222. Now, how much was actually borrowed? Well, if you look back at this example, what they actually borrowed was the $139,920. Which is way less than what was ultimately paid over the course of the loan, the $255,222, right? So to figure out the amount of interest, we take this number and subtract the principal. Okay, interest equals $255,222 minus $139,920. Works out to be $115,302. So the interest on the loan is over $100,000, right? So the length of a loan has a profound impact on how much interest is paid, right? So with mortgages, because they are typically around 30 years or so, the total amount of interest paid is a very large amount for most of these loans. Okay, example 7. Let's suppose that the Petty's family from examples 5 and 6, they're also offered a 15-year mortgage with the same rate and down payment. Find the difference in monthly payment and interest paid between the 15 and 30-year mortgages. Okay, so to find the monthly payment, we still use the monthly payment formula. The only difference between the calculation here and the calculation we did up here in the previous example 5 is that the t has been changed from 30 to 15. All the other numbers stay the same except for the value of t. Okay. So plugging in the numbers, I get 139,920 times 0.045 over 12 over 1 minus 1 plus 0.045 over 12 raised to the power of negative 12 times 15 instead of 30. Okay. And if you do this calculation and work it out carefully on your calculator, you should get a monthly payment of $1,070 and $38. Okay, so that's a little bit bigger. In the previous earlier example, we found the monthly payment to be $708.95. So how much bigger is the monthly payment? So let's see. For the 15-year loan, it's $1,070.38. For the 30-year loan, it's $708.95. Okay. The difference there is $361.43. So they'd end up paying $361.43 more every month for the 15-year loan versus the 30-year loan. But let's figure out how much interest is saved. Okay, so with the 15-year loan, we have the number of payments would be half the number of the 30-year loan. For the 30-year loan, it was 360 payments. For the 15-year loan, that would be 180 payments. So we've got 1,070.38, and there are 180 payments total. So that works out to be 192,668.40. Okay. So the interest paid would be the sum of the payments minus the principal. So 192,668.40 minus the principal, 139,920. So this ends up being 52,748.40. So the amount of interest paid for the 15-year mortgage is a little over 52,000. For the 30-year mortgage, it was 115,300. So it's a big difference, right? So how much money do they save overall, right? So let's take this number and subtract this number, okay? So we would get 115,302 minus 52,748.40. And that works out to be $62,553.60. So if they take the 15-year loan, they are paying about $360 a month more every month. But in the long run, they will save over $60,000 in interest, which is a big savings. So if they can afford the extra monthly payment, it makes a lot of sense to try to pay it off early. Okay, finally, let's talk a little bit about amortization schedules. After securing a mortgage, the lending institution will prepare an amortization schedule. This schedule shows what part of the monthly payment is paid on the principal and what part of the monthly payment is paid in interest. So this procedure outlines how the numbers in those schedules are calculated. Step 1, you would find the interest for the first month using the simple interest formula, where T is 1 month, so that would be 1/12 of a year. And you would enter this value in a column labeled interest. Step 2, you would subtract the interest from the monthly payment to get the amount paid on the principal. Enter this amount in a column labeled payment on principal. Step 3, you would subtract the amount of the payment on principal found in step 2 from the principal to get the balance of the loan. Enter this amount in a column labeled balance of loan. And then step 4, repeat the steps using the amount of the balance found in step 3 for the new principal. Okay. So what does this look like in practice? Let's see. Okay, so we're going to use the exact same loan we've been working with for the previous few examples. Okay, so the amortization schedule looks something like this. You would have a column labeled payment number. Of course, the bank would give you a nice, typed out, nicely formatted one, right? And if it's a 30-year loan, you would have, in this column, you'd have 1, 2, and you go all the way down to, 360, right? You would have a column labeled interest. In this column, the total amount of interest you would pay for each payment would be given. And then you have a column labeled payment on principal. And then you would have a column labeled balance of loan. Okay. So that's the idea. I'm going to just erase this. And so we're going to just focus on what the first 2 rows of this table might look like. Okay. So step 1, we would want to find the interest for month 1 to find the number that goes right here. Okay. So using the simple interest formula, I equals PRT. Remember the principal, the starting principal of the loan was $139,920, and the rate was 4.5%. And for 1 month, that would be 1/12, and that works out to be $524.70. So that's the number that goes right here, $524.70. Payment on principal. Okay, step two, step two, we want to find the number that goes, right here, the payment on principal number. Okay, so remember that from what we calculated earlier, the monthly payment was $708.95, and we're saying that the very first payment, this amount of that payment is interest, and what's left over goes towards the principal. So I'm going to subtract this number from $708.95. So $524.70, and that equals $184.25. Okay, and that goes right here. Okay, and then step three, we want to find the balance of the loan, the number that goes right here. Okay. So that's going to be the principal, which is the $139,920 minus what we have paid on the principal, which is $184.25, right? So $139,920 minus $184.25. So the balance of the loan ends up being $139,735.75. Okay, and that's what goes right here. And then step four, repeat. Okay, so I'm not going to work through the whole thing, but this time when you calculate the interest, my principal is now a slightly smaller number, right? So $139,735.75, right? Times 0.045 times 1/12. Right? So that ends up being $524.01. So that goes right here, $524.01. And you'll find that the payment on principal ends up being $184.94. And the loan balance ends up being $139,550.81. So that's how these rows are filled out. And you'll notice that as time goes on, less and less of your payment goes towards interest, and more of your payment goes towards principal. So this number gets smaller over time, and this number gets bigger over time. And with that, we will wrap up this video here for today. So I hope you found this helpful, and thanks for watching.